Welcome back to another edition of The Explainer. Today we're going on a really fascinating journey. We're going to start with a tiny, seemingly insignificant micro-level coding bug in a Haskell script, but we're going to use that tiny bug to unlock some massive macro-level insights about exactly how we read, write, and mentally process code. Let me ask you this. Have you ever looked at a line of code and felt like your brain was literally bouncing back and forth just to figure out what it means? Like, does the syntax of your language actually force your brain to play ping pong? It's a very real phenomenon. And today, we're going to unpack the psychological elements of reading code that cause this exact mental friction. Here's our roadmap for today. We're looking at the paragraph parsing bug, fixing the parser logic, the power of where, and finally, escaping directional ping-pong. Okay, let's dive right into this. Section 1, the paragraph parsing bug. So the author of our source material was testing out a typed PDF generator for Chinese text, and suddenly they hit a total roadblock. Think about the intended behavior for a moment. You want a cohesive paragraph block that spans multiple lines, right? Exactly how a human expects to read it. But the buggy behavior was completely different. The old parser was failing to handle those multi-line paragraphs. It was treating every single line as its own separate, isolated paragraph. It totally fractured the text structure. And, if you're trying to format a continuous thought, having it chopped up into these completely disconnected lines is, well, it's a mess. Definitely not what you want. Section 2. Fixing the parser logic. To stop all this sentence fracturing, the author needed a real logical fix in their Haskell code. They couldn't just tell the parser, hey, grab a line. They had to actively teach it what a real paragraph actually looks like. And they broke this updated logic down into 3 key steps. Step 1. Capture the first line. They used a helper called line content, which basically just captures a single line until it hits a new line character. Standard stuff. But here's the crucial addition. Step 2. Look ahead for the remaining lines. The parser now actively searches for subsequent lines to see if they belong to that exact same paragraph. And finally, step 3. Stop at a blank line or a header. Because think about it. A paragraph is basically just a sequence of lines, not separated by blank space, and not starting with a header. Simple, right? This step-by-step logic beautifully solved that whole fracturing issue. Moving on to Section 3, the power of where. Now, what's really interesting about this is that fixing this bug led the author to a pretty profound appreciation for the structural elegance of Haskell itself. Stepping back from the mechanical fix for a second, let's explore the tools that made writing this logic so incredibly satisfying. I'm talking specifically about the where keyword. So what is it? A where clause is a local binding that beautifully separates the what from the how. It is just this incredibly powerful tool for breaking down highly complex expressions into named, manageable little components. The really crucial takeaway here is how this totally organizes your thought process. With the where keyword, you get this beautiful separation of concerns. Right at the top of your function, you put the what, the high-level logic, the main story of what the code is actually doing. And then safely tucked away below, in that where block, you put the how, the gritty implementation details. You aren't cluttering up the main narrative with all the mechanics. It reads so cleanly, almost like reading an executive summary right before you dive into the highly detailed report. And this is a very unique syntactic flavor of Haskell. It is absolutely not like these simple let bindings you see in other languages. In fact, the author explicitly mentions wishing that Elixir had a similar default feature. Now sure, Elixir does have private functions called defp, which are close, but they really aren't quite the same thing. There's just something incredibly special about having a default language feature, right out of the box, that actively encourages this remarkably clean code organization from the jump. And this brilliantly illustrates our final segment, Section 4, Escaping Directional Ping-Pong. Let's shift gears from structural organization to the actual physical cognitive load of reading syntax line by line. Should you read code from left to right or right to left? Now, I know that sounds like a crazy question. If you're reading English, obviously, you read left to right. But when you are reading code, a language's syntax can create some serious mental friction. Let's look at the exact experience the author had when writing out their parser logic. Consider a line of code the author wrote right before their final revision. I want you to try reading it left to right, exactly the way you'd naturally read an English sentence. Many, $, try. It gets jumbled almost immediately, right? It kind of feels like an alphabet soup. The absolute culprit here is that little $ symbol sitting right after many. In Haskell, the $ operator essentially acts as a set of invisible parentheses. It basically tells the compiler, hey, wait a minute, go evaluate everything on the right side of me first. And because of that, your human brain is forced to evaluate the right side first, too. It completely disrupts your natural left-to-right reading flow, causing what the author perfectly describes as directional ping-pong. So to fix this, the author realized they could just rewrite the logic using a different operator to make the whole flow way more intuitive. Instead of using the $ operator and dealing with those constant mental context switches, they swapped it for the ampersand operator. This is the reverse application operator. By replacing the $ with the ampersand, boom, you eliminate the directional ping-pong entirely. It creates this incredibly intuitive forward reading flow. You can actually read the logic left to right in the exact order that the actions are taking place. It's a real game changer. Let's just take a second to really absorb this quote from the source material. The author writes about, quote, the directional ping-pong that messes with your flow, forces the compiler and the human brain to evaluate the right side first, causing constant mental context switch. This hits the nail right on the head. The crucial takeaways here is that syntax isn't just some arbitrary set of rules for compilers to digest our commands. Syntax literally dictates human cognitive load. The way a language is structured heavily influences how exhausting or how totally effortless it is for a programmer to read and understand the logic. Which brings us to one final, really provocative question. Does a language's syntax fundamentally shape the way a programmer actually thinks? Next time you go back to your own projects, whether you're writing in Haskell, Elixir, Python, or anything else, take a moment to really notice those invisible structural rules. Are they helping your brain flow, or are they forcing you to play mental ping pong? Thanks for joining me for this explainer, and we'll catch you next time as we continue to unpack the fascinating world behind the code.